Hello, welcome. In this video, we are going to continue with June 2024 paper 1, Cameroon GCE ordinary level 0515. Remember that my main goal is that you acquire the right skills. You should understand the basic concepts in this subject so that you can better perform in your exams, and they will help you in your A levels. And above all, I want most of you, the chemistry student, to be future engineers, to be future pharmacy students, to be future medical students, in agriculture, in different fields of life. I don't ask money. What I want from you is subscribe so that you can continue receiving videos in this subject. Thank you once more for subscribing. Let's get started. From question 14 to 32, we will be starting with question 14. Question 14 has to do with some qualitative analysis. By now, you should have known every area of your qualitative analysis, qualitative and quantitative analysis. In my previous videos, I think we treated that. So for now, you are supposed to know, for instance, you are supposed to know basically your qualitative analysis, the different cations, I mean metals, metal ion that carry a positive charge, their reaction with aqueous sodium hydroxide, their reaction with aqueous ammonia. You are supposed to know all this. Then you are also supposed to know reactions of anions. I'm talking of anions like the carbonates, the chlorides, the bromides, the iodides, the nitrates, the nitrites, and the sulfates and sulfides. All of them, you are supposed to know them. You are also supposed to know test for gases, the different gases, test for ammonia, test for carbon dioxide, test for chlorine gas, hydrogen gas, oxygen gas, and sulfur dioxide. These tests, very, very important as required by the syllabus. You are also supposed to know the different flame tests for metals. We are talking about flame tests for lithium ion, sodium ion, potassium ion, calcium ion, strontium, copper, and the different transition metals, chromium, iron, and the rest, zinc. You are supposed to know the flame tests of all these cations. When you know them, when you know all these qualitative analysis, then you will be able to answer some of these practical questions that we are about approaching now. For example, let me tell you, for example, we are starting with question number 14. Question number 14 says, which of the salts, these are the salts, which of the salts contain calcium ion? You're supposed to know what is a calcium ion. It's a cation, Ca2+. It has a charge of 2 plus. So, calcium ion, if you know your reaction with sodium hydroxide, because the table says salt A, B, C, D, effects on adding sodium hydroxide, effect on adding ammonium nitrate, effect on the flame test. If you go to my previous video on the practical lessons, and on the practical lesson, you will see all these there, well outlined. You can't find it in the ordinary level section. Please, even if you are doing the ordinary level, go to the high school section. You will see it there. The high school section, you will see the practical section of it, well outlined. All these tests are there. So their reactions, the effect of the salt when on adding sodium hydroxide, the effect on adding silver nitrate, and the effect on adding aqueous ammonia, and their flame test. For instance, which of the salt, from question 14, which of the salt contain calcium ion? Let's go to the table. If you have already known the table, I am taking you there because this is what you are supposed to do. If you already know the table, you will know what to do. The salt that contain a calcium ion. If you look at the table on adding sodium hydroxide, you see, go back again to the question. Go back to the question. Okay, which salt is that? That contains calcium ion. Calcium ion contains what? What is the test for calcium ion? It's a white precipitate. So if calcium ion has white precipitate, that is white precipitate that is formed on adding sodium hydroxide. So this table, you are supposed to know it off head, and by doing that, you can memorize. When you get to exam, you see similar questions. You should be able to identify which of the salt. So a salt here, a salt that has a white precipitate is what? A salt that has a white precipitate is A. Remember, we said on adding sodium hydroxide, the one that showed a white precipitate, it was aluminium. It was also calcium. But with ammonia, it is insoluble. But on the table here, you see that it is white precipitate. But giving the what? A flame test which is brick red. So when you know about the precipitate that is being formed, like the white precipitate, okay, what about the flame test? There are two ions, aluminum ion and the calcium ion that form white precipitate. Let's go now to their flame test to see which one has something which is a brick red or golden red, something like that. Okay, and we will eliminate that one. So go now to the flame test. If you go now to the flame test, the flame test for calcium is yellow orange, which is something like that, brick red, something of that nature. That is it for it. So our possible answer in this case, our possible answer in here is, the possible answer we can have here is A. A is a salt which is has a white precipitate on the addition of sodium hydroxide. So we go now, number 14 is A. Now, let's go to the second one, number 15. Identify the salt which could be sodium chloride. You know that sodium chloride has two ions, the sodium ion and the chloride ion. The sodium ion and the chloride ion. Now, the sodium ion, the flame test for sodium ion is, a golden coloration for sodium ion. It has a golden flame test. If you look at it here, you will see that sodium has a golden flame test, a color. This is it here. This is sodium, and we look at it, it has a golden. This is sodium here. Sodium, yellow. It's a golden color, something like that. That is a flame test for sodium. Then, on addition of sodium chloride, on the addition of on adding sodium hydroxide, aqueous sodium hydroxide. Let's see if this is golden color. On adding it, no observable change is noticed. Yes. Then on adding the effect on adding silver nitrate, you should know that silver nitrate, on adding, it has a test with any substance that contains chloride. With chloride ions, it will form what we call a white precipitate. With chloride ion, silver nitrate will form a white precipitate. So C may probably be our answer. Then a reaction with ammonia. If you look at the reaction with ammonia, look at the reaction of ammonia. A sodium reaction with ammonium, you will see that it has no reaction with ammonia. So in that case, there's no reaction with ammonia, but it reacts with sodium with silver nitrate because of the presence of the chloride ion there. So there are two things we have observed here. One, sodium ion that is present there has the flame test is a golden yellow coloration under the flame. That's the color that it gives. Now, on adding these two substances, these two aqueous solutions, silver nitrate, because of the presence of silver chloride, a white precipitate is formed. But on adding aqueous ammonia, nothing changes. In that case, the salt, which is the salt which could be sodium chloride, is C. So let's go to our answer, our answer choices, and you will see that we circle C as our right answer for 15. If we go further again, question number 16. Why is phosphorus stored under water? You will see that there are many options under the answer choices. We have it is stored because it is denser than water. It ignites at low temperature. It is soft and transparent. It is insoluble in water. The right answer for 16 is it ignites at low temperature. We are saying that it catches, that is, with fire, it ignites easily at low temperatures. So answer B is the right answer for this question. 16 is a B. Now, let's go to question number 17. Identify the gas evolved when dilute hydrochloric acid is added to sodium sulfite in a test tube. Okay, if I was to write an equation that dilute sulfuric acid, that is, let me write an equation there. Let me write an equation here for you to say. Let me say dilute sulfuric acid. It's here. In this equation here, I said, okay, dilute sulfuric, let's say sodium sulfite, that is Na2 SO4. Why there's a 2 here is that the sulfate has a charge of -2, and if you look at the sulfate has a charge of 2 minus, and sodium has a charge of 1. So when they exchange their charges, you have 2 comes here and 1 goes here, and that is why you have it like that. Okay, so do not be confused why you see subscripts like that. So let's get back on board. Now you see that there is sodium sulfate, which is aqueous, plus We have hydrochloric acid, which is aqueous. When this react, what will be when this react, what are you likely going to see? Obviously, there's an acid and there's a salt. So what is going to form? This another, they will call a single displacement, where it comes here, displacement reaction here, which we have two, we have sodium chloride. This chlorine will come here, and this one comes here too. So we have sodium chloride. We also have a molecule of water that is being produced. If you look at it from here, this and this one will form, and a molecule of water comes from the hydrogen. Then plus we will have, so sulfur is still left. Sulfur is likely going to give us a sulfur dioxide gas plus sulfur dioxide. This is a gas, this is liquid, this is aqueous because it is still in solution. Let's see how we can balance our equation. Let's see how we can balance our equation regarding taking the number. There are two atoms of one atom of sodium here. Here we have just 2. So in that case, we need a 2 here to equate it. So 2 atoms of hydrogen, sodium, 2 atoms of sodium. Let's go to our hydrogens. Now we have 1 hydrogen here. We have 2 hydrogen here, and we have only 1 hydrogen here. What do we do here? Let's put the hydrogen here. Let's put a 2 here to balance the hydrogens. If we put a 2 there to balance the hydrogens, now we have 2 hydrogens on the left and 2 hydrogen atoms on the right. Now, what is now left? I think the oxygens are the people who are now left. The oxygen will not be, we have 4 atoms of oxygen on the left, and in the right we have 2 atoms of oxygen here and 1 here. So we are lack of 1 oxygen. So how are we going to do this? Yeah, we have 2 sodium, is this sodium? Yeah, sodium sulfide. Sorry. Sodium sulfide. Not sulfate. Sodium sulfide, please. Sorry. Yeah, sodium sulfide. Sorry, please. Made a mistake. Sodium sulfide. So for sodium sulfide is supposed to be 3. Sorry, please. A sulfide is 3, not 2. Sodium sulfide, not sodium sulfate. A sodium sulfide, we are supposed to have Na2SO3. So in this case, there will be 2, oxygen here is 2, plus this one here is 3. So we are now done with oxygen. So with hydrogen, we have 2 hydrogen here, and we also have 2 hydrogen here. With chlorine, we have 2 chlorine atoms here, 2 chlorines here. There are 2 chlorines here on the right, and there are also 2 chlorine here. Let's go to sulfur. There's 1 sulfur here, and there is also 1 sulfur here. I think the equation is balanced. So in that case, our main objective was to look forward. The gas that will be released in this reaction. So the gas that is being released here is sulfur. This is an acidic gas. This is an acidic gas, which is one of the greenhouse gases that contribute in global warming. Sulfur dioxide. Let's get back on board to our question section. On our question section, it was number 17, and we say, now identify the gas involved when dilute hydrochloric acid is added to sodium sulfide. Sodium sulfide, not sodium sulfate. That was a mistake I made. It's a SO3. Now, okay. Answer choices: A, of course, sulfur will be produced. B, C, carbon dioxide can only come from a carbonate, but there was no carbonate there, so this one is off. B is off. Nitrogen dioxide can only come from a nitrate, but there was no nitrate there, so it was a sodium. So off. Carbon monoxide could only come from a carbonate or anything like that, but there was nothing like that. So the only option, even if without writing the equation, you know that carbon comes from a carbonate, nitrogen dioxide comes from a nitrate, carbon also comes from a carbonate. All these were not there. So the only gas that could have resulted is a sulfur, and sulfur came from the sulfide. So logically, you could use that without even writing the equation. So our answer for 17 is A. Our answer for 17 is A. Thank you. Now let's move on. 17 is A, and question number 18 reads. Question number 18 reads. Question number 18. Name the following alkane. Name the following alkane. Remember, in naming the alkanes, you know by now you should be versed with on the E.A.ANDONG system of nomenclature. That I'm talking about, the International Union of Physical and Applied Chemistry, on how to name organic compounds. So now, in naming this alkane, please, the first thing is you have to take into consideration is the parent chain. The parent chain is the longest chain, and with the longest chain is this one up here. This one carbon, this two carbon, this three carbon. So we could do it in this way. We could say this, well, let's use like this. We could say this is the first carbon. We can start from here. If we start from here, let me say 1, let's say 2, and let's say 3. It's the same thing. If we start it from here, because it is 1 and 2 and 3, it's the same thing. So, of course, the methyl group is on the 2 carbon atom. So, according to the E.A.ANDONG system of nomenclature, we now say we start with the number here and then attach the group, which we now say, and the last one will be the parent chain. And now the first thing you should know is the group here is what? CH3. It is a methyl group. Now the parent chain is the longest chain. 1, 2, 3. And 3 carbons in organic chemistry. How do we call it? The first carbon is meth. We can say it's meth. It could be methane and methane. The second carbon is, if we are talking of alkanes, the second carbon is earth. The second carbon is earth. It could be ethane. It could be, if we are talking of alkane, it could be ethane. The third carbon is prop. P-R-O-P, prop. It could be propene. It could be propane. It could be propine, depending on the homologous series. So now, in naming this is the second position. And our side group is a methyl group. So we now say 2-methyl. We now say it's 2-methyl. Then we attach our parent group, which is 1, 2, 3. It's a propane. So we now say 2-methyl propane. And let's go to our answer choices to see if we can do that. On our answer choices, here we have methyl propane. No. According to E.A.ANDONG, is wrong. B, propane. No. According to E.A.ANDONG, is wrong. C, 1-methyl propane is not like that. According to E.A.ANDONG, is wrong. So the right answer here is 2-methyl propane, which is option D. So option D is the right answer for question number 18. Let's go to question number 19. Question number 19 will require your knowledge of the atomic structure, the factors that will affect, factors that are contributing to attraction, polarity in a compound, factors that are contributing to what we call to the strength of a strength in ionic bonding, which are the charge density, the size of the atom or the size of the ion, then the distance from the two ions is also contributing. The charge density, the distance between the ions, and the size of the ion. These are what are contributing to what we are going to discuss now. 19. Which of these carbonate is stable to heat? We are talking of thermal stability. The thermal stability of carbonates. The carbonates are made up of what? Lithium carbonate is a group 1 metal. It's a group 1 carbonate. A calcium carbonate is a group 2 carbonate. Potassium carbonate is a group 1 carbonate. Magnesium carbonate is a group 2 carbonate. So we are mainly talking of group 1 and group 2. So in order to solve this problem, now, which of them is stable to heat? That is thermal stability on heating it. Which one will require more heat to be broken down? And as I told you, it depends on 4 factors: the charge, the size of the atom, and the distance between the ion. So it should be remembered that group 1 carbonates are more stable than group 2 carbonates because of their small size and the high charge. Secondly, once more, I'm saying that in answering such a question, you have to take into consideration that larger cations have less polarity power, and the more stable they are to heat. So group 1 metals group 1 carbonates are more stable than group 2 carbonates because of their small size and high charge. It should also be remembered that when moving down the group, let's say group 1, when you are moving down group 1, the metals become larger and larger because of their increasing atomic size. The metals are increasing as the number of shells are increasing. It is moving. The atoms are becoming larger and larger, and this they become larger and larger and become more stable. So as we go down the group, the atoms become more larger and larger, and they become more stable. Because of what? Because their large cation at the bottom have less polarizing power on the carbonate ion. Larger cations at the bottom have less polarizing power on the carbonate ion. So just have in mind that group 2 carbonates are out of this group. We are looking for the one that is more stable, and they are group 1. So we are not talking on lithium and potassium carbonate. As you move from top to bottom, which one is at the bottom? It is potassium carbonate. Therefore, potassium carbonate is larger than lithium carbonate, and it has a less polarizing power on the carbonate ion. For that reason, it will require more heat for it to be broken down. Our answer choice here is C. C is our answer choice here. Let's go to question number 20. State what happened in the formation of bond in sodium chloride. Sodium chloride is sodium chloride is a combination of sodium is a metal, and sodium is a metal, and chloride and the chlorine is a non-metal. They have different electronegativity. Because of the difference in their electronegativity, that is, chlorine is more electronegative than sodium. For that reason, it draws electrons from sodium. It has a higher tendency to draw bonding electrons from sodium. So for that reason, electrons will move from sodium to chlorine. In other words, chlorine will be accepting or will be receiving electrons, but from sodium. And let's go to our answer choices. and see which is the right choice for this question. Sodium atom accept electron from chlorine atom, unacceptable. B, chlorine atom accept an electron, chlorine atom accept an electron from sodium. That is reasonable. As I said, because of the high electronegativity, it will tend to draw electron from sodium. So our right answer is B. 20 is B. A chlorine atom accepts an electron from a sodium atom. 21. Which of these is a crystalline allotrope of sulfur? There are many crystalline allotropes of sulfur, but which one is a crystalline? Which one is required here? A, plastic sulfur. B, colloidal sulfur. No. C, rhombic sulfur. That's good. Flowers of sulfur. No. So the right answer choice for 21 is C. 21 is C, rhombic. Question number 22. State a gas which is a respiratory poison. Carbon monoxide, you know it. Carbon dioxide is not poisonous, as you think. If carbon dioxide was more poisonous as you think, the whole world, I don't think there would have been any living creature in the world. Because carbon dioxide and acetic acid, is one of the greenhouse gases that is in the atmosphere, causing global warming. Maybe there would have been no living creature that takes in oxygen. So carbon dioxide is not poisonous, but the other one, carbon monoxide, is the one that is poisonous. So I don't need to go to nitrogen dioxide, which is in the air. I don't need to go to sulfur dioxide, which is also a greenhouse gas. I don't need to go to nitrogen monoxide, which is being produced maybe in engines of cars. But carbon monoxide, which is carbon monoxide, is extremely toxic than other gases. So our answer is A. Question number 22, our answer is A, which is carbon. I said it is extremely toxic than other gases, carbon monoxide. Question number 23. Question number 23 has to dealing with transition metals. Transition metals beginning from scandium right to zinc. From scandium right to zinc. Those are the transition metals. The question reads, transition metals form colored compounds in a solution and are used as catalysts in industrial processes. Which of the following element forms a blue precipitate when its ion react with aqueous sodium hydroxide? Once more, we are going back to the table we did, the table that was given to us here. Copper is a member. Copper is a transition element. Copper is a transition element. If you look at the periodic table, copper is a transition element. So now, within this transition element, which of it is going to give a blue? Which of it is going to give a blue precipitate when it reacts with aqueous hydroxide? Look at here. If you look at the table here, you will see that the blue one is the one that gives is a B. And if we go back to my reference center, which I have advised you to go when preparing for the exam, try to know your qualitative analysis, take it down, study it very well, know the cations, know their reaction with sodium hydroxide, know their reaction with aqueous ammonia. When you get to the exam, you are going to succeed. So among these, chromium is a transition metal, copper is a transition metal, iron is a transition metal. But which one will give a blue precipitate when reacts with sodium hydroxide? It is a copper ion. If it is a copper ion, then copper is the element that will do that. Let's get back on board. So question number 23. Which of the following element forms a blue precipitate when its ion reacts with aqueous sodium is copper. So please go back and study it qualitative analysis. You can go to my previous video or open the A-level video. You will see them there. Okay, so our answer choice for 23 is an A. Is A. We don't need to go. Now, 24, an element. 24, an element that is used as a catalyst in industrial manufacture of ammonia. Of course, in the Haber's process, which I know you should be versed with it, in the production of ammonia and in the industrial sector, a finely divided ion is being used. An ion, as I told you, is a transition metal. So we don't need to go looking for it again. The answer is C. Number 25. Number 25 has to do with some calculations. We are saying this is stoichiometry. By now, you should be versed in your stoichiometric lessons, how you can calculate volumes that are being produced from chemical, from combustions of substances, how you can calculate substances amount or the mass of something that is being produced. Let's get back to the question. Ethanol, relative molecular mass of 46 grams per mole, burns in oxygen according to the following equation. Ethanol plus oxygen, that's a complete combustion. Ethanol plus oxygen gives carbon dioxide plus water. Calculate the volume of carbon dioxide formed when 1.7 grams of ethanol is completely burnt at RTP, that's room temperature and pressure. Yes, as I told you, this is a stoichiometric equation, a stoichiometric problem. The quantities. You are lucky that the equation has been written. That's one thing you would have been asked to. At the A levels, you will be asked to write the equation and use the equation to calculate this. But at this level, you are lucky that the equation has been given. So let's see how we can solve this problem. They said, calculate the volume of carbon dioxide formed when 1.7 grams of ethanol is completely burnt at room temperature and pressure. You should also know the volume occupied by a gas at room temperature and pressure, which is, remember, 1 mole of any gas at room temperature and pressure, that's RTP, occupies 24,000 cubic centimeter or 24 dm cube. But at standard temperature and pressure, it is 22.4 or 22,400 cubic centimeters. So let's get back to the question. See how it is being solved. Good thing I told you the equation has been written, so you don't have any problem. What you want is the gas that is being produced. So here we are targeting ammonia, ethanol, and we are also targeting carbon dioxide. You have been given the mass of carbon dioxide per mole. Remember, the molecular mass is 1 mole of that substance. Now, the molecular mass of carbon dioxide here is carbon dioxide is 12. 12 plus 16 times 2, which is 32. 32 plus 12 is giving us 44 grams per mole. Please do not put the moles. Do not put the moles. Don't multiply it by 2. We will use that later on. Okay? Now, we have been given 1.7 grams of ethanol. What you need to do here is method number 1. You have you know that to have the number of moles, you have to divide the given mass by the molar mass, and the molar mass have been given. So the given number, the given gram is 1.7 grams of ethanol divided by 46 grams of 46 grams of ethanol times 1 mole of ethanol. I am putting this 1 mole to cancel out, so that when the grams they cancel out, the number of moles will remain. Okay, I use this to cancel so that the number of moles will remain. This is how it is here. Here we have that 0.03 moles of ethanol times 2 moles of this. This is what we will have. Now, these are the number of moles of carbon dioxide that are being produced. As I told you, remember that 1 mole of any gas at room temperature and pressure, ROTP, occupies a volume of 24,000 cubic centimeter or 24 dm cube if you were calculating in dm cube. Accordingly, using this value, if 1 mole of carbon dioxide, I say 1 mole of any gas, if 1 mole of this carbon dioxide that we are dealing with occupies 24,000 cubic centimeters, then the moles, 0.07 moles that we got from 1.7 is what? 0.73913 moles of carbon dioxide will also occupy what? Let's do the calculation. It will be 0.073913 times 24,000 cubic centimeters. And the total volume we are going to have will be 1,174 cubic centimeters of gas that is being produced at room temperature and pressure. Method number 2. If you cannot do that on an examination condition, the shortest thing you can do is this. Since the equation has been written for you, just look at the number of moles. The number of moles are the coefficients. These coefficients here. Okay, here the coefficient of ethanol here is 1. So it has only 1 mole of ethanol. Reacting with 3 moles of oxygen will give me 2 moles. The coefficient is 2 moles of carbon dioxide and 3 moles of water that are being released. Let's deal with our target is who? Ethanol and carbon dioxide. I said during examination condition, use simple proportion. This is a simple proportion that I'm using now. 1 mole from our equation, 1 mole of ethanol produces 2 moles of carbon dioxide, since we are looking for the volume of carbon dioxide. Therefore, the number of moles that we got, or the number of moles that we can get from 1.7 is what? Remember to have the number of moles, the mass divided by the molar mass. So the number of moles will be 1.7 gram all over 46 per mole. Will give what? Will give 0.073130. That is it. So if we do this and we do our calculation, cross multiplication, 1 times 0. This and divided by this one, this is what we have. If 1 mole of ethanol gives 2, then this other number of moles will give this other one. So if we do that multiplication, this is what we are going to have. Okay, so that's good. So it will be 1774.0 cm cube. The moles will cancel out and the cm cube will remain. That is the shortest way, simple proportion you can use in calculating it. So our volume is 1774. So let's go to the answer choices and see where we can find that. And the answer choices on question number 25, 1774 answer is a D. That's our calculation. It's a D. Question number 26. On question number 26, you are going to say this. On question number 26, this is what you are going to say. An organic compound which decolorizes bromine water is what? Remember, these are some of the tests you are supposed to put into you are supposed to study very well. The test for double bond, a test for double bond, for example, alkenes, they have double bond. They have a test, and the test is the one that decolorizes bromine water. That is bromine water in tetrachloromethane. Bromine water in tetrachloromethane. When bromine in tetrachloromethane, or what we call the bromine water, when mixed in an organic compound containing a double bond, it decolorizes it. You will not see the color again. The color disappears, and that is the major test we give for alkenes. And which of the alkenes is here? Ethane is not an alkene. Ethene is an alkene. Ethanol is not an alkene. Ethanoic acid is not a thing. So the right answer is B, because ethene is an alkane. Good. So our right answer is B. 26 is B. 27. Question 27. Consider the following equation. Nitrogen plus hydrogen to give ammonium in the ratio 1:3 to give 2 moles of ammonium. Which of the following changes produces more ammonium? Remember, they say which of the following changes produces more ammonium? Okay, the production of ammonium, even though it is not indicated here, the production of ammonia, even though it is not indicated here, if it was indicated by the energy change, enthalpy change, we would have known that the production of ammonia is an exothermic reaction. This is an exothermic reaction, but we have not been given here. Deal with the information you have been given. Deal with the information you have been given. So in that case, we are going to deal with the information we have been given. The information given here is that this is a gaseous reaction. Nitrogen is a gas, hydrogen is a gas, ammonia is a gas. This is a gaseous reaction. And what is going to influence our reaction? The only factor that is influencing a chemical reaction in terms of gases is pressure. We cannot, temperature acts, but we cannot deal with temperature because energy change value has not been given. We don't know whether it is an exothermic. We know that it is an exothermic, but we cannot do it because it has not been given in the question. So we are going to be dealing with pressure. So with pressure, see what is going to happen. And for dealing with pressure, this is what happened with pressure. Okay, if you have a reaction, increasing the pressure will do what? Increasing the pressure means you are decreasing the volume. If you have a balloon, the more you compress it, you are doing what? At the same time, you are reducing the volume. And when you reduce the volume, there's more collision of particles. So in that case, the pressure is going to be too high. And then according to Le Chatelet's principle, if a system in equilibrium is subjected to any change, the system must react in such a way to oppose the change that has occurred. In that case, we are not going to be going, since there's going to be more pressure, so we have to go to the direction of less pressure. As we are increasing the pressure, it has to, according to Le Chatelet's principle, it has to oppose and go back the reverse direction. So we need to go back to a region where there's less pressure. And when there's less pressure, we have less molecules reacting there. So summarizingly, increasing the pressure of a gaseous reaction will favor the direction of moles, direction of fewer moles. It will favor the direction of fewer moles. So let's get back to our question. So here we are increasing the pressure here. Increasing the pressure here will, there are 4 moles on the reactant side. There are 4 moles on the reactant side, and there are 2 moles on the product side. So increasing the pressure will move the equilibrium to the right, and that will lead to more production of ammonia. So our answer choices are what? A decrease in the concentration of it will not work. An increase in temperature of reactant, it will not work. An increase in pressure will work. So our answer is C. Be careful. Go to the front desk. Welcome back, please. Just as I said, an increase in pressure. An increase in pressure will lead to the production of more ammonia. Let's go to question number 28. Ethanol reacts with concentrated sulfuric acid at 107 degrees Celsius. Give the major product. Remember that concentrated sulfuric acid is a dehydrating agent. It removes the molecule of water that is being produced. So we don't need to go further in reacting ethanol with it. There's going to be a dehydrating reaction that an elimination reaction that helps that ethanoic acid is going to absorb the water molecule, leading to what we call the formation of ethane. So question number 28, we'll go to the answer choices. Is not ethanoic acid. The major product is not ethanoic acid. The major product is not ethyl ethanoate. The major product is not ethanol. The major product is ethane. Option D is the right answer. Question number 29. Question number 29. Identify the element that will react with nitrogen of the air. Identify the element that will react with the nitrogen of the air. It should be noted that nitrogen, I think, is one of the I think it has 78% in the air. It's one of the most abundant element in the air. So the element that will react with nitrogen of the air. Nitrogen reacts only with lithium and magnesium to form a nitrite. You know, with nitrogen has a triple bond, and that triple bond renders it very, very unreactive. The double bond in the nitrogen makes it very, very unreactive because it will require a lot of energy to break down to overcome the triple bond in the nitrogen molecule. So for that reason, nitrogen reacts only with lithium and magnesium to form a nitrite. So it reacts only with the S block elements. So in that case, there's no lithium here. There's no lithium here. It's only magnesium. Nitrogen does not react with calcium. It does not react with potassium. It doesn't react with sodium. But magnesium is the only one. So 29B is the right answer. Let's go to question number 30. From 30 to 32, we have many options. The instruction is, for each of the question, one or more of the responses given is or are correct. Decide which of the response or responses is or are correct. Then choose. Choose A. If option 1, 2, and 3 are correct. Choose B if option 1 and 3 are correct. Choose C if option 2 and 4 are correct. And choose D if only option 4 is correct. So, now, what do we do here? We are starting with question number 30. So, just know that apart from D, at least you will have 2 options that are always correct. Now, let's get started. Number 30. Oxidation is defined as what? You should know from your from your previous knowledge in oxidation and reduction, that oxidation can be defined as loss of electron. Oxidation can also be defined in terms of oxidation number. You can also say it is increase in oxidation number. Reduction, on the other hand, you can say it is gain of electron or a decrease in oxidation number. Now, you could also say oxidation in terms of oxygen. You could say oxidation is the addition of oxygen into a compound. When we are doing oxidation, a redox reaction or oxidation in organic reactions, oxygen is used in the oxidation process. So addition of oxygen to a compound is also defined as oxidation. Again, you can also define oxidation as removal, as removal of hydrogen. Addition of oxygen to a compound, removal of hydrogen, and loss of electron. These are the these are the possible definition of oxidation: addition of oxygen, removal of hydrogen, and the loss of electron. So we cannot say it is only 1 and 3, addition of oxygen. We cannot say it. We can say it's 1, 2, and 3. A. So 1, 2, and 3 are the possible answers. So our answer here is A. So question 30 is A. Question 30 is A. So we have A here. I can put this in. Question 30 is A. I don't know where to put it. Yeah. Question 30 is A. Or you can circle it here. Yep. Now, question number 31. Question number 31. Okay. Now, from the equation, sulfur dioxide plus oxygen gives sulfur trioxide. Now, see what I told you the other time, the energy change has also been given. It's negative. It shows that it is an exothermic reaction. It shows it's an exothermic reaction. Now, which of the factors, when introduced, will shift the equilibrium to the right? Shifting the equilibrium to the right. 1. You can shift the equilibrium to the right since how many number of moles are on the left? 2 moles of sulfur dioxide and 1 mole of oxygen. It means 3 on the left and 2 on the right. So I said increasing the pressure, high pressure will shift the equilibrium to the right. At high pressure, the equilibrium will move to the right. It will lead to the production of more of the sulfur trioxide. So 2 is one of our answers. Shifting it to the right again, because it is an exothermic reaction, lowering the temperature will favor the exothermic reaction. So lowering the temperature at low temperature, so 2 and 4 are possible answers. High temperature, no. Low pressure, no. So 2 and 4 are the right answers. And 2 and 4 will give us, if we look on our chart here, 2 and 4 gives us C. 2 and 4 will give us a C. So question number 32. Question number 32. A mole of oxygen contains 6.02 times 10 to the 23rd atoms. 2, 32 grams of oxygen, 32 grams. 3, 16 grams. And 4, relative molecular mass of 48. Which is right? It should be recalled that this Avogadro number is very, very important. What is a mole? How can you define a mole? Basically, we can say a mole, we can define a mole, the mole can be defined as the amount of substance that contains as many elementary particles as there are in 12 grams of carbon 12 isotope. So, in other words, we can say 1 mole of any atom, or for example, a monatomic element like sodium, like helium, like argon, like magnesium, a monatomic element. 1 mole of a monatomic element will consist of 6.02 times 10 to the 23rd atoms of that element. So, in other words, you should also know that a mole is a unit. This is a unit. That is a concept. Is a concept referring to a unit to measure the amount of substance. So a mole is a unit used to measure the quantity of a substance. I said it's a unit that is used to measure the quantity of a substance. It represents a specific number of particles. The mole represents a specific number of particles, such as we are talking of atoms, electrons, protons, molecules. But this time around, we are talking of atoms. So this number is the Avogadro's number, and it represents the number of atoms. It also represents the number of molecules. It also represents the number of ions. So 1 mole of oxygen atom, as the question requires, it will contain 6.02 times 10 to the 23rd oxygen atoms. Not oxygen molecule, oxygen atoms. And you know 1 atom of oxygen, when we look at its molecular mass, it is 16 grams of oxygen atom. It is 16 grams of oxygen atom. This refers to the specific quantity of oxygen atoms, oxygen atoms. But if we are referring to a molecule, we cannot be timesing it by 2. That value by 2. So a mole is a unit used to measure a quantity of a substance. 1 mole of oxygen will contain 6.02 times 10 to the 23rd atom. So number 1 is right. And I said this number is also equal to 16 grams of oxygen atoms. So number 1 and number 3 are the right answers. Number 1 and number 3 are the right answers. And if I go to the answer sheet, 1 and 3 are represented where? It's a B. 1 and 3 are as a B. So B is my right answer. Okay. Fellow learners, we will get to the second session of it, beginning from question number 33. For today, once more, go back, read, or revise your qualitative analysis. Reaction with reaction of cations with aqueous ammonia, aqueous sodium hydroxide. Also remember the flame test in the laboratory. Also remember the test for gases when you are going for your exam. Thank you once more. If you have not subscribed to my channel, please subscribe. Remember that I am not asking for money. My goal is that you people should succeed in chemistry, understand the basic concepts, so that tomorrow you could be good. You'll be admitted in colleges of education, colleges of engineering, colleges of pharmacy, colleges of medicine, and many other colleges. So have a nice day. Bye bye.